Hello and welcome to a new video here on the Lötwig Fusel channel. In today's video we're going to continue on our game engine series. So what we want to do now is we want to write a renderer. However, before we can write a renderer we need to make sure that we can actually write shaders, because well, in DirectX 12 it's not as straightforward. In DirectX 12 we need to have a compiler to compile shaders, and I want to have a few features done before we're gonna start the renderer, so that we can work a bit more nicely with the shaders. So in a classical environment, what you could do is you could just download the shader util, you can just compile the shaders, and then you can just drag and drop them into the project and use them. However, this is not kind of a good approach. What I want to have is I want to have them to compile automatically. So I want to include my shaders somewhere within the structure of my project. Probably it's going to be the app directory, because this is where our ImGUI ini is. This is our working directory, and yeah, what I want to kind of like do is I want to also have the shader somewhere in there, so that basically the content of our editor and the content of our game. All of these like basic contents, they shall be inside of the app directory, and they then shall be compiled later as soon as you publish the application to a binary package, so that you can then run without these. We can delete that one, by the way. Now, to do that, we need some kind of build pipeline. So we need to kind of like detect that if we have a folder here, let's call this one content, because this is going to be the content of our game. And if I have a folder here called shaders, this is where all of my shaders will be. I want to have like my dummy.hlsl. I'm not sure, because maybe, do we get already some syntax highlighting on there? Probably, because it's HLSL, it's Microsoft, so it should be already implemented. Or did I install an extension for this? HLSL. Did I install one? No, I did not install one. Interesting. But there are a lot of extensions, but I think I don't need any, because it's Visual Studio Code, it's a Microsoft product, HLSL is Microsoft, so it is already there. So, okay, so we already got the shader. Now I want to grab quickly some shader that we can put in there. Let me quickly find a shader that we can put in there. One second, I have like this project that I once prepared. I've written like a shader that will be quite similar to our shader. It's not exactly similar like the pixel shader here, it's completely different. If you open up the pixel shader, it's there's a lot of going on here. However, what we're going to have is we're going to have a quite similar vertex shader, which is basically an empty vertex shader in this case. And we're going to have a quite similar geometry shader in terms of what it will do, because what we're actually going to do is we're going to use the geometry shader. Maybe we also going to explore a bit of mesh shading, because what we're going to do is write a 2D renderer, and I can later on, as soon as we're getting to writing the renderer, I want to like introduce you on what we are doing. However, what I want to do is just quickly copy us together the simple shader. So that one, that vertex shader. As you can see, this is using some includes and some in-out data that we kind of like need for that one. It's not defined yet, so it's using that pipeline and that bind.hlsli. HLSLI include directives. We don't need that binding one, because we're not going to use some binds. However, we're going to need the defines, but we're not going to need anything, or not everything from these defines. We need the root signature for that, so I'm going to paste in the root signature. However, I'm going to also change the root signature, because basically what we want to start with is we want to start with an empty root signature, so something like that should be allowed. We should be able to just do a simple root signature like that. And I also don't want to have that prefix here that was like project dependent. I want to remove that one. Okay, the next thing is this in-out, which I also want to change a bit. I don't think that we can change it that easily, because there needs to be some metadata attached to that. How was that called? SDF quad pos was what it was called. It was that one basically, which well, there's also the vertex format. Why did we had this one in there? Yeah, because the vertex needs to be produced by the geometry shader if we are using a geometry shader. So actually what we need is we need that, and basically we just need to define that one. So basically we should be able to just specify a simple vertex shader like that, and that's it. That's everything that you would need for very basic shader. Okay, now the tab should be out there. Okay, alright. And I think this one should give you a compilable shader, so that we can now use just to dummy out and compile a bit of things around. Now what you could do is just simply download the Microsoft Shader util and start running with these. So we can do that. It's called DirectX Shader Compiler. This is the upstream source. You should more or less always use that one. You can see that it's quite frequent in terms of commits. Yesterday was weekend, but they still committed. Well, okay, that's nice. That's nice that Microsoft. I don't know. Is it a thing? It's actually a guy from Google. Okay, interesting. Yeah, there's like a lot of people are working on that one. It's open source. That's really nice that the shader compiler is open source these days. And you can more or less just work with it. I think it's not for Xbox. If you want to go for Xbox, you need to actually have a different compiler, which probably is just a branch of the shader compiler. It's probably not in here, but it's probably just a branch of that one. With some additional features, but I don't know. I don't really know what Xbox does. Now what we want to do is we want to download the latest release. It's May of 2024, so it's 2 months old. Yeah, it's more or less quite accurate, 2 months old. So you can see it's quite recent. And what you're going to find is you're going to find multiple zips. I don't know what the heck to use here. What you probably want to do is just use the first one, the plain and simple one. I don't know why there is the Klang CL one and why there is the normal one. I would just take the normal one. I've always used the more normal ones, and yeah, this is the shader. So what we want to do now is we want to somehow entangle this into our project so that we have the shader available. So what we of course need is going to be all these licenses. Maybe they are also annotated in the, let's say, header file. Let's see. If we open the header file in that one, yeah, you can see that the license is also annotated here. So for the headers, that's already good. Now, basically what the headers are, these are APIs. So in the end, what the DirectX Shader Compiler from Microsoft is, it's basically a compiler that's shipped with an exe. So if you look in here, you can see that there is the exe.exe, and there's also a DLL version of the compiler. So basically what this means is that you can either call the compiler out of your application or by calling the exe. Now what we want to do is we want to of course have both of these options available for us, at least for now. So we want to have the include and we want to have the exe. So we're not going to put this into source, even though we have a vendor folder, which would be a good place. But what I want to have in here is, I want to have in your folder external. So these are going to be now all of our external components that we have no control. Like we are compiling it. It's still some source. It's not our source, but we are compiling it. This is different for the DirectX 12 shader compiler. So DXC, this is going to be the subfolder here, external DXC. And we're going to take that folder in here. And now we're going to go to what we downloaded. And basically what we do is we just take everything that we have in here and we copy it over. So basically we have the complete DXC in here. There's a README. There are all the information about that. All other files are with that license, MIT and MS. You should consider these licenses and how they work. That's really important. I've already done that and I know that I can do what I want to do with it. Like there's a Microsoft license and everything. But you should always take care of licenses, of course. Okay, so now we have the DXC in our project. Now we could simply just start by compiling a shader. By going in here, okay, so now you can see app content shaders. And what we could do basically for binary and x64, we could quickly copy the path to that folder, and then what we can do is cmd append to path. Like there's a way that you can actually make this callable. And what you would do now is you would run set path equals path semicolon and then paste that one in. I don't know. I think we should add a trailing slash. And if you are setting that command, you should be able to run DXC. Okay, now you can see DXC failed. Normally, if you... Okay, so if we open another CMD, maybe I should have shown it that way. CD app, CD content, CD shaders. If you would say DXC here, you can see that it's not recognized as an internal program. I don't know why it's CD'd in there. But as soon as you're setting this path here, you can see that DXC works. It only is for that current shell, but it just makes our calls and our play around a bit more useful. Now what we can do is we can do DXC help, which is going to give us all the options that we have for DXC, which are actually quite a lot. I think if we just want to have a very, very basic compilation, we should just be able to do the... maybe we need to define an output file object. We can try it without any of the specification of the outputs. I think the only thing we need to specify is the profile, so what kind of shader we are doing. So we would compile a vs6_8. So if I would try that quickly, vs6_8, of course it doesn't work like that. We need to have the input file. So you can see that there's the options and then there will be inputs. So I think if we are now saying dummy.hlsl, we should already compile. Okay, so why did I not? Yeah, because of course I cannot write the profile directly like that. You need to do -t and then the profile. Okay, so -t and then the profile. Okay, what did that do? Interesting, that's interesting. We don't know what happened here. I think it's actually fine what we got. If we go into contents, shaders, no, we did not get any output. Input signature. Okay, so actually we just, I think, compiled the shader, but we did not output it to a file. So basically we have now our compiled shader in the console. So we need to tell it that it needs to output that. I think we can do it if we scroll a bit up, and we should have the -fo, which is the output file object. So after the profile.fo, I'm going to call this one dummy.cso, compiled shader object, and now, okay, you can see that we have the CSO file. And if we open this up with the text encoder, yeah, now you can actually see that we have an encoded shader object, which is a DX BCVT, whatever. This is like the magic of the thing. You can see our SV position in there. You can see our main in there. So there are a bit of readable stuff along these encoded things. But this is now our shader. We have successfully compiled a shader. However, I would need to do this every time manually and then reference that. So basically I would need to remember that command, and every time I change the shader I need to recompile it, and after I have recompiled the shader I would probably need to restart the application, and that's all things that I don't like. I would like to do this all with the API and with a programmatic way of doing that. Now this seems a bit over-engineered for something that I advertise to be plain and simple and straightforward. But just because it's plain, simple and straightforward doesn't mean that we are going to have useful features. What I want to have is I want to have a build system. I want to have build steps. I want to have like input files that are processed through a certain process chain that allow you to generate the contents of your game. I don't want to have basically to manually compile it every time. It is not going to make it more straightforward. So what we need to do is we need to now include these headers and the library, the dxcompiler.lib. We now need to add them to our configuration, to our project, so that we can use them. Now what I'm going to do is I'm going to go to my mocks.lua, and you can see that we already adjusted a bit of the include dears in the function setup projects. And basically what I'm going to do is I'm going to add a DirectX shader compiler in here. Okay, so we're going to go to external DXC, and then the folder is called inc, which is the include folder. So now we have the include directory ready. Now what we also need is we need to have a library directory. So maybe let's go quickly to premic5.github.io, and if I'm in here we can go and search for, I think it's called libdirs. Yeah, it's just called libdirs. I just need to verify that because I have never used it for quite a while. Or never used this wrong, but not used it for quite a while. And basically what we want to do is we want to add the same directory, but this time we're not going to go to the include directory. We're going to go to lib. And then what we're going to do is we're going to go to x64. I think we should have a token to make this a bit more, less error prone. Like there's some tokens. And there should be the configuration short name. This is the one that we should use, I think, here, the configurations.shortName. And we can use, I think it was a different token. It has a different prefix, right? No, it's okay. Tokens. Okay, so it's the same token, but I think they had a different prefix sometimes. No, okay. Alright, maybe it just was hallucinating. So now the library directory, it has been successfully included. And now the only thing that we need to do is we now need to reference that library here, the dxcompiler.lib. That needs to be referenced now. I don't want to do it in here. I don't want to always reference it. So what we should do is we should add it where we need that. So where do we need it? We need it basically in our final application, but only if we are like in debug or development. During release, we don't need the shader compiler. So what we could do is we could go into our game and alter our game in build.lua, right? You can see that we already have our links in here that hard-coded. Okay, so that's something that we in general should need to change. Okay, so maybe we're just going to quickly hard-code the DX compiler in here as well. So maybe then we add a to-do, remove on release. For now, it's not too bad if we have that in here. Well, maybe let's add another to-do, automatically generate this. So in the end, basically what you would want to do is you would want to make sure that things like that, like the setup on how a game works with the links and to the projects, the links to the projects and the lib to the links to the libraries, this is all something that you do not want to do on a per game level. You want to define a pre-make function for that. But since we are not so deep into all of that things yet, I think for now it's fine. Alright, so if I do that, and let's make a new command line quickly, mocks init, to quickly refresh our project so that we can all see that. I want to show you how bad this will fail. Okay, so why is this going to fail badly? Because, well, you're going to see. Let's run that, let's compile it quickly, and I'm gonna show you how it fails. Maybe it doesn't fail, but it should fail. I think it should fail. Maybe it does not fail, it depends on. But I think it should fail. And it does not fail. Okay, so it does not fail because we are probably not using. We are currently not using our things. So if I would quickly go into game and quickly just make sure that we use it. So d3d compiler.h, this should be the header that we just included. So if we go to that header, you should see, no, that's actually coming from... Okay, that's interesting. That's not good that we are not using our new one. Okay. It's called D3D12 shader DXC API. Okay, DXC, because yeah, the D3D compiler is the old compiler, but DXC is the new one. DXC API is the new one. This is the new shader compiler. And there you go. Now we have it, and there you can see it. Why is it freaking out a bit? Interesting. It's probably going to work. I don't know what the hell it does now, why it has some problems, but I think with just including that one, we should make our application fail. Maybe we need to use it. It's interesting that it fails that badly. It's failing because we're not having Windows. Probably that was the reason. If we have Windows in there, it should no longer fail, I think. Okay, yeah, but it still does not fail the way that I want it to fail. It does not fail because probably we're not going to use it. The thing is, as soon as we use it, it's going to, the whole world will burn. It's I think this one that we should call. That's the function that we want to call to make it fail. It's an update. We don't have a constructor for our empty game yet. That's okay. So let's maybe quickly put this into update. It's not really a big deal where we put it in. Even we think we can just populate all of that with null pointers. It's not possible to do that with a CLS ID. Okay, so maybe quickly, let's quickly find out how to use it. If we go to the wiki here on GitHub, we're going to find how to use it. I haven't done this in quite a while, but that's okay. Where is it? Where is it? Where is it? Language versions, debug, compiler bridge, compiling, byte address, building sources. There should be one. Ah, down there. This one. This one should give you the option on how to use it. This is basically just one example for the whole shader. It's a bit insane, but yeah. This one. That's what we want to do. Basically, it's not everything that we want to do. I don't want to have utils. I just want to have the compiler quickly, and I think we would need our comp pointer. I think the comp pointer is not included by Windows. Did I include that? Yes, I did include that. Okay, that's nice. So then we would not need to include the comp pointer. I haven't worked on my own project for quite a while, so I'm sorry for that. So let's make this a comp pointer. Okay, and now this should fail. Okay, there you go. Now we have it. The code execution cannot process because DX compiler DLL was not found. Reinstalling the program might fix this problem. Okay, so basically what a deal is, it needs a DLL. Now, how do we get a DLL? Now, we could get a DLL into multiple ways. You know that we already have it in external DXC and we have it in bin. There is our DLL somewhere. There is it. There is the D3D compiler and the dxel.dll. However, I don't want to go and copy them to my build directory. I also don't want to copy them while building. What I want to do is I want to kind of like patch them in at runtime. Now, how can we patch in a DLL at runtime? I'm going to show you. In our app directory, what we're going to do is we're going to do a env.json. This is called environment.json. This is just a JSON that I'm now defining. There is no format associated to that. And what I'm going to call this one is I'm going to call this one DLLs, or let's maybe call this one, let's maybe keep this a bit platform independent, and let's call this a bit different. It's going to be an array with everything that we need to later on include. So how are we going to call this? I'm going to call this one binary, or let's call this external libs. And I'm going to specify now external lib dirs. So external library directories. This is what I'm going to call that one. And basically what I want to do is I want to include, go one directory up, external, dxc, bin. This is what I want to load. I think it's x64, the subdirectory. There we go. This is where I want to now load some DLLs. Okay, external lib directories. Now what do I want to specify? External libs. Okay, so now we are going to specify which external libraries I will need. Now I could now maybe have some specifications so that this only works on Windows and some only works on Linux, but I think for now we can just maybe we'll rename this in env.windows.json. Let's maybe call it like that, env.windows.json, and if we once going to move to Linux, we can make a Linux one, and if we have some shared dependencies across them that named the same, we could make them shared, or we could just have them in both. Now what I need is I need this compiler.dll. Okay, let's copy that one, close it, and call it a day. dx compiler. That's what I need. This is how I want to now define that. Now we have a bit of a problem because we don't know JSON yet. Our application has no plan on how to interpret JSON. So what we will need is we'll need some JSON library. Okay, we can just search for JSON, and there are a lot of JSONs, and actually the one that I want is nowhere near. Interesting. There it is. nloman JSON. That's the JSON library that I want to use. We copy that talk in here from Conan. We go for self requires and nloman JSON. Quickly run a rerun that, mocks in it, and there we go. Call it a day. Now, just because we have that in here, it's not going to mean that it will magically no longer care about the usage of the DLL. So as you can see, it still fails, right? It still fails, it's bad. It's bad. And actually it should fail even before we hit that line of code. Actually, yeah, we don't even hit the line of code, it directly fails. Maybe we could also go in here. Yeah, but it basically doesn't even start executing my code. The Excel loads. Microsoft loads the exe, it sees the dependencies attached to it, and then it's going to try to find these dependencies, and if it doesn't find these, it's going to fail. So what we need to do is we need to kind of like convince Windows into not loading these DLLs on itself, which is called delay load DLL. Verzögertes Laden, whatever. Delay load DLL is what we want to have, and I think Premake should maybe have delay load. I'm not sure. DLL. I think, well, maybe it does not do that. So in general, this is now a German document, so I need to switch this to English again. The linker has an option to delay load certain libraries. You can see that if you are calling CL, the compiler, and you're also linking it, you can see that you can specify something called delay loading. And basically what this delay loading is going to tell, it is going to tell that the library will be loaded later. Okay, so delay loading basically means loading a DLL not at the application start. I think there might be a pragma for that we could specify, but I think the option for the command line is probably the best one. So what we need to do is we need to specify, even through as it seems I'm not allowed to copy, is that we need to define this delay load argument as a linker argument. Okay, so linker parameters, is it here? I'm not sure. Arguments, command line arguments, no, linker args. Okay, so it's called in Premake link options. All right, so what we need to do is we need to specify these link options, and we need to tell the linker that it shall not require our library. Okay, so we go in here, and then we say link options, like that, I think. And then we're gonna tell it to delay load our DX compiler DLL. Maybe we need to add the slash. I'm not sure if we need to add it. I have never played around for quite a while. Again, I'm talking completely rubbish. I have never for a while did that. So the slash, what I wanted to do, link options. I wanted to check that I've pronounced that one right. Okay, so let's try it out. Delay load DX compiler. So let's quickly init that and see what it does. If the linker option is done successfully. So if we go into that, we can quickly go into our empty game. We can go to linker, and we can go to all options or command line, I think. And you can see, yeah, the delay load is in there, but it has not added the slash. It's ignoring some error, but it has not added the slash. So we need to add the slash here exactly. So we do it like this, and then we run the init again. Okay, has initialized again. And now we should be able to run our application, finally. So we should be able to now hit the breakpoint. The whole world will burn after the breakpoint. Okay, what's now your problem? Delay load helper 2. That's interesting. Okay. So we have some problems now because we're using delay loading. It could be that if we are delay loading, we need delay imp. We need to use delay imp.lib. User32 and delay imp.lib is required. Otherwise, delay loading doesn't work because it's some runtime feature that needs to be linked into the code. Okay, so we have these ones in here. So let's paste the user lib. I think user should be already there because it's a quite common thing that should be always there. But let's just explicitly put both in there. And let's reload our project. And now this one should at least build again. And it should also hit the breakpoint now. Okay, because, yeah. Okay, so now you can see we hit the breakpoint. That's good, right? Can we continue? Yes. What does now happen if we call the function? Burns. The whole word burns. Module not found. Okay, so basically what happens is actually as soon as a library is required, it's going to go to the delay load helper too. I'm not sure. I think you can actually write your own function for this one, for this delay load helper. But basically what happens is that it tries to delay, if you define to delay load a library. Now, it basically calls this function. If it is not loaded yet, it will call this delay function that it was just not able to find now, that we included with the helper. And this function now tries to actually load the DLL, but it is not able to load it. So basically, if hmod equals 0, it raises that exception, right? We should be here in raise exception that it was not able to find the module. Why was it not able to find it? Because it tried to get that. Where is the hmod defined? So it's dereferencing that from some pointer, and that pointer is, I don't know. It somehow tries to find the DLL, but it doesn't find it, right? So we have a bit of a problem. Now, how can we fix that? We can call the load module function. If we call the load module function, we can load a DLL on our own. And for even being, can we do raw? Yeah, we can do it like this. And if we are loading a DLL manually, we can specify the path from where we load the DLL, right? So we have in the folder here, in the binary folder, we have the compiler.dll. If I copy the path from the compiler DLL, and if I paste the path in here, okay, then you can see that we load some module. What is the problem with load module? Parameter 2 could be, what is the second parameter? Maybe we need to put the right second parameter. Let's see if we could write second parameter block. Is it really the load module function that we want to have? It doesn't seem like the right one. Is it the right function? No, because load module is loading in exe. That's not the right function that I want to have. What was the function called again? C++, load DLL from path. There should be, load library. Exactly, load library is what we want. Of course, not load module. Okay, so load library is what we want. Let's say load library R, and then we also don't have this odd parameter. We just specify which library we want to have, and we call it a day. Just a load library. This is returning an H module. I think we can just ignore it, because we really don't care about that. But as you can see, now I called load library. Now, this one is not really changing much, but you're going to see that now magically our application doesn't fail anymore, because we basically loaded this DLL. Also here, the compiler is loaded, the compiler 3, we have a pointer and I unknown. Everything is now looking to be good. D3D dxcompiler.dll is also in here. Everything seems to work well. You can see it now looks good. It's all good. Now it works, yay, but now we just need to make it work with our JSON file that is describing how it should work. Well, how can we do that? Now basically what we need to do is we need to do this while our engine loads, or to be even more precise, when the Windows engine is loaded. So we have the on OS init and the on OS shutdown. So you can see here we are loading all of that stuff, but what we actually want to do is we want to load something more. So you can see these are the common things that we have in our Windows engine. And what I want to do is I want to define a namespace in here, Windows. I think we should already have that one, right? We have the Windows window is in engine. No, it's all directly in engine. That's okay. So we can make it on Windows, or right, yeah, let's just put it in the Windows namespace here to just prevent the names from cluttering. And I'm calling this one void load required DLLs. Okay, so this function shall now load all the required DLLs. Loads all external / delay loaded DLLs required for operation. Okay, so that's quite simple. Now we can go in here I can create the implementation, and there we have the function. Now I'm just going to call that function here, Windows load required DLLs. Alright, so how are we going to do that? Well, we have the engine context here, we have all of our includes here, so maybe let's then also add our includes here. So what we need now is we need enloman json.hpp. And what we can do is we can say enloman JSON, that's the object that we want to have, and we want to call this one Windows env. This is our Windows environment file. Now we want to load that one from the disk. So what I also would want to need is I would need the hashtag include f stream, so the file stream. Okay, so how do we now load this file? Well, we're going to say, okay, std stream file in. I'm just calling this f in, and the only thing that we need to specify is where we want to load the file. So maybe let's use the file system for that. File system, okay. So std file system current path, so the working directory. And then inside of the working directory, I'm looking for the env.windows.json file. Okay, so now we have it, now it's good. And now basically the only thing that I need to do is I need to say, okay, the file in goes to the Windows env. This is how simple you load a file to enloman JSON. Now this is not accounting any issues. If you have any error in here, this function will fail. But since we are writing a game engine, this file is always preset. I am just not caring about making too much of the error handling. This file will be always present. We will always assert that this file is present, and we are all good. For later on, gonna probably change that, but for now, it's good. Now, basically what this means is we now have the whole definition file in memory. So what I'm going to do now is I'm going to write a for loop, and I'm going to iterate now over the array of modules that we want to load. So if you recall our file, we have the external libs. These are all the libraries that we want to load now. So for auto reference, so we can actually make a const auto reference, lib in Windows env dot external libs. You can do that with enloman JSON. And this one is should now be, I think, a string. But how can we access the string? I think we should be able to just call the get function. The get for std string. That's the only thing that we should need to do. So let's maybe auto call this one lib name, okay? And then we're going to get a string. I'm just going to make a breakpoint here. I'm just going to see if we hit it. Okay, so let's run. And we hit the breakpoint, and it's called DX compiler. It's in here, the lib name is good. So okay, that worked. So now we have the lib name. So what we now need to do is we now need to find the actual library. We're going to do that with a nested for loop. For const auto lib dir. So for a lib directory in that certain folder, okay? How is that called? Not folder, in that certain JSON array, okay? So that JSON array, we're gonna iterate it. And then I'm going to auto call that lib dir name equals libdir.get std string and this. And then we're gonna go and do an auto DLL pass. Now we are checking the actual pass to the DLL. And this is going to be std file system current path slash libdir name. So we go to the directory slash libname. That's where we want to go to. And now I just want to make a breakpoint and see if we hit that and what the DLL path is, if this is all good. Okay. So the, where is it? The DLL path, it's edef / external dir dx compiler. Okay, so this works. The path has been correctly set up. Now we just need to append the DLL ending, DLL path, replace extension to .dll. Okay, so now it's called .dll. And now we're going to do if std file system exists DLL path and std file system is directory, not is directory in this case, then what we can do is load DLL, and then we're going to break out of this inner for loop because we found the DLL, we don't need to continue it. Okay, we can make quickly a breakpoint on the break and see if we hit it, if that works. Okay, so we hit it, so it seems like that this file is existing. Okay, so now that the file is existing, what we can do is we can call the load library function, actually now the W1, because we want to have a wide path. Okay, going to take a V string, and we're going to take a C string from the V string, and now we are going to load the library W. And this should now automatically, with these folders and this JSON definition, loads all of our libraries. Let's maybe quickly, so that I can show you again that it's working, uncomment that here. Go into our empty game, we have here our breakpoints. Let's run this quickly. And we're going to show you that it fails again. And then we're going to comment that in again. Okay, failure, doesn't work. Okay. So let's go back here. Let's remove the comment. Let's run it again and see how it performs now. Okay, click, click, doesn't fail. DLL has been loaded. And now we have a lot of infrastructure available to load DLLs on demand. And that's everything that I wanted to do. Now we have successfully integrated DirectX shader compiler without the nasty things of copying things around. And this is going to be proven quite useful, because as soon as we are going to load more and more dependencies on there, so maybe if you are going and use some NVIDIA APIs and things like that, this is going to be your friend. Because NVIDIA libraries, if you're using NVIDIA libraries for game dev, it's a bit cumbersome because they sometimes install themselves into a certain defined location, and they should just set an environment variable where they are. And what we can then do inside of our mocks.lua, we just specify the environment variable and load it from the environment variable. And then what we can do is with that one, we should be able with these paths to also specify maybe environment variables. Maybe I should not have the current path there. Maybe we need to later on change that, because the dot slash is saying more than enough. And if we are later using environment variables, it's probably not going to work. Yeah, so maybe let's remove that quickly. I think this is not a good idea. So we do it like that. Should still work as desired. Yeah, now we are every frame creating an instance of the DirectX compiler. Okay, or did I remove the code? No, I did not remove the code. Okay, so we're doing that's every frame. Oh, that's nice. Okay. So we did not progress quite far, but we did implement some very, very important infrastructure code. Now, again, the build system, it's not perfect. We still have a lot of work to do until we get at a certain state where it will be good. But we have something in here, and it's really important to understand what we have now. We have now a quite flexible system. Even if we would want to load some Windows DLLs, we could do it, right? External libs. Okay, so that's everything that we want to do for now. In the next video, we're going to start a bit with the pipeline and actually using that library to compile it. Maybe we're going to first explore how we can compile it from code, how we can compile that shader object from code, and then we might go into how we can implement like a tool chain. A simple like chain that is detecting all files at the startup of the engine, noticing the build passes, and if a file changes, re-triggers the build passes. And I might also have a bit of a filter in here so that you can run certain build passes only at like baking and not at runtime. So basically we need to have a system that's flexible enough to decide if it is running at development or release. So yeah, that's really, really handy, and yeah, we will get to the actual meat in that. You're gonna trust me. This might now look a bit complicated, and yes, the repo is a bit convoluted, but I've seen more complicated repos, the Mono project. Okay, so thank you for watching, see you in the next video, make sure to like and subscribe, and have a nice day. Bye!